Hello everybody! Let's start the journey of this academic year with this very exciting chapter. In this chapter, we'll be learning about different aspects of motion such as distance, displacement, speed, velocity, acceleration. We'll also be learning about Newton's 3 laws of motion, and we'll also be considering and discussing various examples that we actually encounter in our daily lives. So my name is Huzefa, and let me take you through this very exciting chapter, Laws of Motion. So let us start by understanding what is motion. Now if we observe this slide over here, we can see there is a person sitting on the bike right now, but the bike is not moving. And we have two people over here on the footpath, even they are not moving. Now here the signal is red, but as soon as the signal turns green, we know that this guy moves. That means he changes his position. Now since he changes his position, we know that he was in motion. So how do we define motion? A body is said to be in motion when it changes its position with respect to its surroundings. So that means this person on the bike, he changed his position. But if we see these two people over here, they are not changing their position. That means they are right now at rest. So how do we define rest? A simple change. A body is said to be at rest if it does not change its position with respect to its surroundings. So now that we have understood what is the technical definition of motion, now let us understand types of motion. And we have two types of motion with us, that is uniform motion and non-uniform motion. Now what is uniform motion? Let us see the definition first. The definition says a body is said to be in uniform motion when it covers equal distances in equal intervals of time. Now if you see the example over here, we know that the hands of the clock, they cover equal distances in equal intervals of time. That means the hands of the clock are in uniform motion. Now if I ask you a question, is the clock in uniform motion? What would your answer be? The answer would be no, the clock is not in motion because the clock does not move. Only the hands of the clock are in motion. So hands of the clock are in uniform motion. Whereas non-uniform motion is nothing but a motion in which an object covers unequal distances in equal intervals of time, right? So even here we have equal intervals of time, even here we have equal intervals of time. But in uniform motion, it covers equal distances, but here we have unequal distances. Just remember this, right? Now let's see the second point. Second point says the distance time graph is a straight line, and here it says that the distance time graph is a curved line. This line can be of any shape but a straight line. Now what is a distance time graph? We'll understand this when we understand the concept of graphical representation of motion, right? So when you understand what is graphical representation of motion, at that instant of time you will understand as to why the graph of uniform motion is a straight line. Let's see the next point. The next point says acceleration is 0, and here there is acceleration. When we actually understand the concept of acceleration in a while, we'll understand why in uniform motion the acceleration is 0 and here there is acceleration. And the final point we'll conclude by writing the example. And here the example is a car moving on a straight road with constant velocity. Now if it is moving with constant velocity, we know that it will cover equal distances in equal intervals of time. And here we have an example of a ball which is actually dropped from the roof of a tall building, and we know it will cover unequal distances in equal intervals of time. So this was the distinguished, or we can say types of motion, that is nothing but uniform motion and non-uniform motion. Now after understanding this, let us understand the first two physical quantities of this chapter, that is nothing but distance and displacement. So first of all, what we should understand is that distance and displacement both are denoted by small letter s. Now let us understand distance and displacement with the help of an example. So here we have a circular track with us, and we have train right now at point A. Now this train wants to move from point A to point B, right? So what or which path will this train actually cover? This train will actually move like this, right? And this is the actual path which is travelled by this object, right? So this is the actual path travelled by the object, and this particular thing, this particular path is called as the distance. And this statement has to come in the definition. So let's see what the definition exactly is. The length of the actual path traveled by an object in motion while going from one point to another is called as distance. So this is the definition of distance. Now let us understand displacement with the same example. So here it started from point A, reached point B, and it took this path, right? But what is the shortest path between A and B? It is nothing but a straight line, right? So this straight line is nothing but the shortest distance, and this is what is called as displacement. So the minimum or the shortest distance between the starting and the finishing points is what is called as displacement. So this and this is the definition of distance and displacement, right? So these were the first points. Now let's move on to the second point. It says that this is a scalar quantity and this is a vector quantity. Now scalar quantity means it requires only magnitude for its description, and here it is a vector quantity, which means it requires magnitude as well as direction. So distance, a scalar quantity; displacement, a vector quantity. Now the third point. It is either equal to or greater than the displacement, and if you see over here it says it is either equal to or less than the displacement. Now what exactly is this? Now we saw the example of the train and we know that the distance was something like this, right? And displacement was like this. If the train would have actually traveled like this, the distance and the displacement would have remained the same, right? That means the distance can be either equal to or greater than the displacement, right? And one thing what we should understand is that distance traveled is always positive, whereas displacement may be positive, negative, or zero, as it is a vector quantity and vector quantities have directions. So minus means only the direction will change. It is not a negative physical quantity, right? So one final important thing is that we should always remember that when object moves in a straight line, distance and displacement are nothing but the same, they are equal. And one last thing is that the unit of distance and displacement is the same, that is meter, and this is the SI unit, remember. So what will be the CGS unit? CGS unit will be centimeters. So this was about distance and displacement. So after understanding what distance and displacement is, let us come to next two physical quantities, that is nothing but speed and velocity. First thing, speed and velocity both are denoted by small letter v, remember. And one very important point, speed is related to distance, velocity is related to displacement. That means in the definition of speed, we should have distance. And in the definition of velocity, we should have displacement, remember. Let us see the definition of speed first. So speed is the distance traveled by a body in unit time. So it is the distance traveled by a body in a unit time. Let us understand this with the help of same example that we considered a little while earlier. Now we know that this train wants to move from point A to point B. To do so, it will take this path. So this is the total distance traveled by the object. Let us say this distance is 10 meters. So this 10 meters is nothing but the distance. Let's bring this distance over here, right? Now let us assume, it's just an assumption, that it takes 1 second to cover this distance. That means this 1 second is nothing but unit time. So in physics, whenever we say 1, it means unit. So we have unit time. So let's bring unit time over here. Now if we divide these two terms, that means we are dividing distance and unit time. When we divide this, what we actually obtain is nothing but the formula for speed. That means speed is equal to distance upon time is the formula. So let us bring this formula over here. So we have speed is equal to distance upon unit time. You can also write this formula as speed is equal to distance upon time. So this was about speed. Now let's talk about velocity. In the earlier part of this distinguished, we also understood that speed is related to distance and velocity is related to displacement. That means in the definition of velocity, we should have the word displacement. Speed is the distance traveled by a body. Distance traveled by a body. Here we should write the displacement that occurs, because displacement is not traveled, it just automatically occurs. So velocity is the displacement that occurs in a unit time. Now the formula for speed is equal to distance upon unit time. Now think and tell yourself what should be the formula for velocity. The formula obviously will be velocity is equal to displacement upon time. Now one more thing. You remember I said distance is a scalar quantity and displacement is a vector quantity. And if speed is related to distance, that means speed also becomes a scalar quantity. That is what the third point is. It is a scalar quantity and here it is a vector quantity. That means velocity obviously is a vector quantity. Let us see the final point. It is always positive or zero but never negative as it is a scalar quantity. We have already discussed this, and here it may be positive or negative or zero. So this was about speed and velocity, which is a very simple understanding. Now we have talked about speed and velocity as physical quantities. Now let's understand the units of speed and velocity. Now the formula for speed is distance upon time and the formula for velocity is displacement upon time. But why are we discussing formula when we have to discuss the unit? Always remember one thing. If you forget the units of any physical quantity, what you should do is you should remember the formula. Now let's see how to derive the units using these formulae, right? Now let's see. Now we have two systems of units, MKS and CGS. MKS stands for meter, kilogram and seconds. CGS stands for centimeter, grams and seconds. Now let's see over here. What should be the SI unit of distance? It should be meters, right? That means we bring meter. And upon time is nothing but seconds, so we have seconds over here. That means the SI unit or the MKS unit we can say of speed is meters per second. Similarly, when we talk about displacement is also meters and time is seconds. That means if you see properly, the MKS unit of speed and velocity is nothing but the same, that is meters per second. Now guess what should be the CGS unit for both of them? Done? I think you are absolutely correct, and the answer should be centimeter per second for speed as well as for velocity, that is centimeters per second. So what we have understood in this module is nothing but four physical quantities, that is distance, displacement, speed and velocity.